Good afternoon, Professor. I'm going to present the topic which is interaction applied with atom and materials to Professor Giago by Brahim. So the outline of my presentation is introduction of light, material interaction with light, optical properties, atomic interaction with light, followed by application and references. So as we have the introduction part, what is the nature of light? Light is basically light is a form of electromagnetic radiation that shows both behaviors, wave and particles. So the wave properties is confirmed by the Young double slit experiment, and the particle property is confirmed by Einstein by following this equation: E is equal to hv, and the wave particle is confirmed by C is equal to lambda v, where C is the speed of light, lambda is the wavelength, and V is the frequency. So as we can see here in this figure, the wave behavior of the light, that light consists of the magnetic field and electric field. And in this case, in the second picture, if we see the incident light fall on the surface of the material, and because they absorb the light and electron ejected from the surface of the metal, so we can see here the particle behavior of the light. And if we want to see it combinedly, so as we can see here, this is the wave like and this is the particle like, and when it combines, so we can see here in this picture. If we talk about the atomic energy level, so as we already know that atom consists of a nucleus surrounded by electron in discrete energy level. Light interacting with atom can cause electron to move between these energy levels. For example, if an electron absorbs a photon of specific energy, it moves to a high energy level, which is called excited state, and when the electron falls back to a lower energy state, so it emits a photon, as we can see here. So now my focus was the interaction with material. So we can see that when light hit a material, several things can happen, and it depends mainly the properties of the material and the wavelength of the light. So it may be absorption, reflection, transmission, scattering. So here in this picture, the last one, if we can see that if incident light fall on the surface of the material, it may be absorbed, it may be reflect, it may be that the scattered, and it may be it happen the diffraction and maybe refraction. So here we can see here only in this picture the absorption phenomena. When incident light fall on the object, so the light absorbed and we can't see anything. Here also they transmitted light, but it depends on the wavelength of the light and bandgap of the material. For example, the properties of the material that I already discussed here in the first sentence. And here in this picture also they shows the scattered waves, and in the second one, the middle one, when the sunlight fall on the material, so as we can see here that the atmospheric particles and the light scattered in every direction. So now generally different materials, how the light interact with the different material. For example, conductor, insulator, semiconductor. As we already know that conductors there is a low band gap between the valence band and the conduction band. In case of the insulator, and this is a too much band gap as compared to the conductor, and in case of the semiconductor, this is the intermediate level. So here in metals, free electron allows light to be reflected. Metal typically don't absorb much visible light, which is why they appear shiny. And in case of the insulator, light may be absorbed, but electron can't move easily, meaning the material doesn't conduct electricity. And in case of the semiconductor, like silicon can absorb light and generate charge carrier electron in holes. This is the basic principle behind the photovoltaic cells, behind the solar cells. And if we already know that spectroscopy is a study of the interaction between the light and matter, and our topic is the interaction of light and matter, so spectroscopy is a technique, it's a study which discuss the light and matter. So by analyzing how atoms absorb and emit light, we can determine the composition of material, their energy level, and other component important properties. For example, the UV spectroscopy and the X-ray spectroscopy used for the analyzing inner electron transition in atom. Now we have the optical application, which is really important in the light and matter interaction. So light interact with the material in many ways. So the first one is luminescence, the second one is lasers, the third one is thermal emission, and the fourth one is photoconductivity, and the fifth one is optical fiber. So the first one is luminescence. As we can see here, that what is luminescence? So the first is where a material absorbs energy and then immediately emit visible or near visible radiation. So this phenomena is known as luminescence. For example, it consists of electron excitation and then dropping down to a lower energy state. Here we can see here that but there are two types. For example, if the emission of radiation, for example, we can see here the emission of radiation. If the emission of radiation happened within 10 power minus 8 seconds, so that's called fluorescence. And if it takes longer than 10 power minus 8 seconds, so this phenomena is known as phosphorescence. So as we can see here in this picture, the phosphorescence, this one is the phosphorescence and this one is the fluorescence. If it happened within 10 power minus 8 seconds, it's called fluorescence, and if it happened within 10 power minus, not within 10 power minus 8 seconds, it's called phosphorescence. And we have, if you want to find out the intensity of the luminescence, so we can use this equation: I is equal to I naught exponential minus t power divided by t. And we have different types of luminescence. For example, the phosphorescence, fluorescence, triboluminescence, chemiluminescence, bioluminescence, and radioluminescence. The second one is laser. So as we already know that from this figure, the laser is consists of the light amplification by stimulated emission of radiation, and by laser we can produce the coherent light. In coherent light, the light produced by laser emission is coherent. So this is the photon absorption and emission. For example, the absorption here is they shows the absorption phenomena when photon fall. So the electron goes to the high energy state and then come back, and there happen the spontaneous emission. And there is also the phenomena happen stimulated emission, which is photon come here and then two photon emitted. So that's called the stimulated emission. And here the third one is the thermal emission. When a material is heated, electrons are excited to high energy level, particularly in the outer energy level where the electrons are less strongly bounded to the nucleus. So these excited electrons, upon dropping back to the ground state, release photon in the process, which is called the thermal emission. So as we can see here, the thermal emission. And if you want to find out the intensity of the thermal emission, so it depends on the temperature. For example, in case of we here in the y-axis and the y-axis we have the spectral energy density, and in the x-axis we have the wavelength. The fourth one is photoconductivity. So what is photoconductivity? The bombardment of semiconductor by photon with energy equal to or greater than the band gap. As I already explained that it mainly depends on the band gap of the material. So the band gap may create electron hole pair that can be used to generate current, and this phenomena is known as photoconductivity. It is different from the photoelectric effect in that an electron hole pair is generated whose energy is related to the band gap energy instead of the free electron alone whose energy is related to the Fermi level. This phenomena is utilized in photographic light meters. Cadmium sulfide is commonly used for the detection of visible light as in light meters. So photoconductivity is also underlying principle of the photovoltaic cell or solar cells. And the last one is optical fiber. So what is optical fiber? Optical fiber have revolutionized the communication industry, and it primarily consists of the core, cladding, and coating. For example, we can see here the core, cladding, and the coating. And in this picture we can see here the multi-mode fiber. This one is the multi-mode fiber and this one is the single mode fiber. For example, when light falls, so it can move only in a single way, and in this case the light can fall in different way. So the core transmit the signals while the cladding can send the light beam to the core. The outer coating protect the core and cladding from the external environment. And typically both the core and cladding are made up of special type of glass with carefully controlled indices of the refraction. And once the light enters the core from the source, it is reflected internally and propagates along the length of the fiber. And internal reflection is accomplished by varying the index of refraction of the core and cladding glass material. And here usually they design two. For example, the first one is single mode fiber and the second one is multi-mode fiber. Now we have the atomic interaction with light. As I already discussed the interaction of light with the material, now I'm focusing on the atomic interaction with light, how the light interact with the atoms. So for example, it consists of the absorption and emission, and specifically emission consists of the spontaneous emission and stimulated emission. So when an atom absorbs light, when an atom absorbs light, the energy from light excites an electron to a high energy state. This is called absorption. So, example, if the energy of a photon matches the difference between the two energy level in atom, absorption occurs, depending on the band gap of the material. And when the excited electron returns to its original energy state, it releases energy in the form of light, and this process is known as emission. So, the examples of this is fluorescence, where an atom absorbs light and re-emit it at a lower energy, which is the longer wavelength. So, absorption, electron move from ground to excited state. Spontaneous emission, return to a lower energy and with proton release. And the stimulated emission is excited electron triggered to release a photon, and this mechanism is called stimulated emission. So, the first one is absorption, the middle one is spontaneous emission, and the third one is stimulated emission. Now, we have some applications. For example, the first one is solar cell. So, in solar cell, light is absorbed by semiconductor material, causing the generation of electron hole pair. This leads to current flow, which can be harnessed to generate electricity. So, we have we need the clean and green energy, and for that purpose, the solar cell is one of the best technique to produce the clean and green energy by using the sunlight to convert directly into electricity, and it based on the interaction of light with material and interaction of light with the atoms. So, solar cell is one of the best application in this case. The second one is light emitting diode and laser. So, laser operate based on the interaction of light with atoms, where electrons are excited to high energy level and then fall back to the lower levels, emitting coherent light in the process. And the example of this case is barcode scanners to cutting edge medical devices that we already use in some hospitals and some laboratories. That's really important application also. And the third one is nanotechnology and metamaterials. So, metamaterials and engineered nanostructures can manipulate light in unusual ways, such as bending of light around an object, which is simply called diffraction phenomena. An example of these is graphene and other 2D material have unique optical properties. The fourth one is spectroscopy. As I already discussed, the UV spectroscopy or some other spectroscopy technique which used to analyze the material, analytical tool to study material composition. So, to know about the material composition, we use the spectroscopy, which based on the interaction of the light with the materials. And the last one is medical imaging, for example, X-ray, fluorescence microscopy, and some other techniques which we are used in hospitals or some other laboratories. So, the medical imaging is also a best technique. So, these are some important application: solar cell, laser, nanotechnology, and metamaterial, spectroscopy, and medical imaging. And these are the references that I took some materials from these stuffs. So, obrigado.